you could have studied science and mathematics in more than 12 years before you want to make a decision whether to continue to study mathematics or science in the university level, which is another 4 years of your studies, or you want to do something new like business or engineering. Question is, why should you do science and mathematics as opposed to doing other subjects? Is science and math still relevant? You know that many of the stuff you learn in your schools, like in physics, math, seems to be the work of people from 200, 300, or even 400, or even thousands of years ago. Like in Pythagoras, his theorem was discovered 2,000 years ago. So question is math or science still relevant today? Okay, look at this picture. If you, those of you who study math or physics, you may recognize some of these people. The lady on the right is Madame Curie. The person in the middle is Gauss. You learn normal distribution, you learn Gaussian distribution, and then you know this is Newton. Okay. So question is science still relevant today? Now I'd like to introduce to you SPMS, the School of Physical and Mathematical Sciences, and tell you what is it like to study chemistry, mathematics, and physics at the university level. How is it different from your secondary school science and physics and mathematics? Okay, and I'll tell you more about the features of our program and what our graduates do after their degree. Now, NTU is divided into several colleges. We have College of Science, College of Medicine, Nanyang Business School, and College of Engineering, and other colleges. College of Science is one of the smallest, and within the college, we are further divided into smaller units called school. And SPMS, School of Physical and Mathematical Sciences, is one of the school in the College of Science. And SPMS, we have 120 faculty members split into 3 disciplines of chemistry, physics, chemistry, mathematics, and physics. We receive about 500 undergrads per year. Although we are one of the smallest schools, we are actually one of the most active in research and development. We have a lot of strength, which I'll tell you about later, in very cutting-edge research topics. We have more than $30 million in research funding every year. And you can see that we are actually quite advanced. We would say that we actually punch above our weight in R&D. These are our education programs that we have, with the latest addition in chemistry with a second major in business, international trading. These are 4-year direct honors program. I don't go into details, but basically we can categorize them in 3 main categories. Basically, you have a single major. In this single major, you do a major in the main discipline, and then you graduate with a single major, possibly with another minor. And then the second type of program is the program with a second major. For instance, chemistry with a second major in business, chemistry with a second major in food science and technology, and so on. For this type of second program with a second major, you work extra hard. Basically, you work roughly about 1.5 times. You put in 1.5 times the amount of work as compared to the single major. Why is it 1.5 times but not 2 times? Because we remove some of the duplicates. For instance, if you do a chemistry with a second major in environmental science, the program is specifically designed so that you don't have to duplicate a lot of chemistry knowledge. And you can jump right ahead and take advanced courses in environmental sciences. Okay, and the third category we have is the double major programs. These are programs in which you do basically almost like 2 degrees. So you have to work very, very hard. These are very selective programs, like double major in mathematical and computer sciences. These are newest. double major, and then double major in mathematical sciences and economics, and double major in physics and mathematical sciences. So basically, you know, for instance, let's say you do double major in mathematical and computer sciences, you basically are trained in as much as those who are in single major in math and those who are single major in computer science. You know basically everything in the two single major. All right. So for the detailed curriculum, we would like to refer you to our website. And in the website, you can see details in the courses. Now, as I said before, we have three core disciplines of sciences in SPMS. First one I'd like to go into is the discipline of chemistry. And what is it like to study chemistry? Chemistry and biological chemistry, I would say, is a very, very relevant subject. Most of our students choose to major in this because this is a foundation to a huge part of our Singapore economy. The energy and chemical sector actually contributes to 1/3 of the volume of Singapore manufacturing output. Our graduates go on to chemical-related industry like pharmaceutical, or analytical chemistry, which is like, you know, you analyze things like chemicals in the air, water, and some of them go into government R&D institutions. You can see all this logo here. These are actual companies that our graduates have gone on to work with, like Shell, ExxonMobil, Micron, and all these are very well-known multinationals. So with these very important applications of chemistry to Singapore economy in mind, we have a very rigorous curriculum. The key feature of chemistry and chemistry training in our graduate degree is that we are very, very focused on lab skills. So if you look at the curriculum, basically in every semester, there will be at least one laboratory work. And this is a very, very hands-on discipline. What's more, you get to use very advanced equipment. You get to use very, very advanced, I would say even very, very expensive equipment that you may not have come across in your education. These will be multi-million-dollar pieces of equipment, things like MNR, these are very expensive, X-ray spectrographs, and so on. So we really bring our students to the latest cutting edge of technology, and you get to work with state-of-the-art chemistry equipment in the lab. Now, we are very proud to say that chemistry is actually one of the most highly ranked subjects in NTU. In fact, we are top 10 in the world, according to the QS World University Rankings. And in the US News rankings, we are number 4 in the world, not just in Asia, No. So both of these are very prestigious ranking organizations that are highly respected throughout the world. Now, some of examples of high quality of graduates which we produce are like Miss Ng Si Xuan here on the right. She's a winner of the whole Singapore for the World Skills Singapore competition in chemistry lab technology. And she went on to represent Singapore in Russia for the World Skills Chemistry Lab competition in Russia. And here another one, we are very proud to say another one of graduates. He actually joined NUS as a President Assistant Professor, a very prestigious appointment in NUS. And he actually graduated from us and went on to do a PhD, and then now he's in NUS, President Assistant Professor. So you really can go all the way based on our NTU SPMS education. This slide I will not go into detail, but if you are interested in the cutting edge chemistry research, you can go to College of Science blog and you search chemistry, and there are many interesting research going on in our school. Let's move on to another discipline, which is the mathematical sciences. Now, mathematics is another topic which is extremely important in the modern world, especially in Singapore, as Singapore moves towards more and more knowledge-based economy. It is more important to have people who are trained in quantitative skills, especially in mathematics, statistics, data analysis, data science, and so on. So the two main areas in which our math graduates end up working with are banking and finance, okay, as you can see on the left, and also IT and data science. And these are the only two, and much more. There are other companies, there are other types of companies that our graduates have joined. These are the only two main areas. And let's give an example to how mathematics actually have real-world implications. So many of you use internet for transaction, and you know that when you sign on to, let's say, important website, for instance, banking website, when you want to enter into some transaction, the connection is actually encrypted. So you can see HTTPS, the S is for secure, and you have actually encryption. What it means is that even if people can tap in and listen in, they actually can't figure out what is being communicated between you and your bank. Why? This is because of the work of mathematicians who have developed very sophisticated encryption protocol. As the internet evolves, we need more and more highly customized encryption algorithms. So there's one class of them which is called authenticated encryption algorithms. These will be used in the next generations of internet connection protocols. So some of professors in SPMS here in NTU, School of Physical and Mathematical Sciences, they are actually the world expert on this. For instance, we have this competition which is called Caesar competition, which happens once every few years. This one took part in 2018, 2019. Here, the US National Institute of Science, Institute of Standards and Technology organized, sponsored this. They want to develop the next generation encryption protocol, and they conducted this competition. There are 6 categories, and our professors, Professor Wu Hongjun and Professor Thomas Perrin actually won 3 categories out of the 6 categories. So this gives you an idea. We're actually really at the cutting edge of this very, very important area of mathematics. But there are other areas that we are very strong in, but because of time, I only highlight this. So move on to studying mathematics as a college subject. Because mathematics is such a vast and flexible discipline, we deliberately design our curriculum in such a way that it is as flexible as possible. So in first year and second year, our student will study the foundational courses. But then in year 3 and year 4, you are free, we open up, and you're free to select one of the 4 areas listed here: the pure math, applied math, statistics, and business analytics. So you can really shape the curriculum to suit your interest. Here are some examples of student testimonial from our students who have gone on to different careers. One as a cryptologist. There are data scientists. There are programmers in GIC. GIC, very big company in Singapore. And interestingly, there's even one, Miss Lia Ning, who graduated in 2014. She went on to study medicine, as postgraduate degree at Duke NUS Medical School. So you can see, you can really end up doing anything if you have a math degree. Now, physics and applied physics. This is the third discipline in the SPMS I want to mention. Physics, what is it? Physics actually is the study of nature in the broadest possible sense you can think of. So the thing that distinguishes physics as an area of study as compared to other sciences is that physics really is a very even mix of theory, laboratory work, and programming or computational skills. Okay, so physicists, you can say that physicists are actually jacks of all trades, and we train them accordingly. Those of you who do physics in secondary school and JC will realize that physics not only involve theory like Newton's and Einstein theory, but actually a lot of work is in the lab. So we train our students accordingly. If you do physics, you learn a lot of cutting-edge theoretical ideas. You learn mathematical methods, computation skills, and you also get a chance to use cutting-edge technical tools. And then you learn how to combine theory and experiment, and then to analyze data, and so forth. Okay. So similar to mathematics, in year 1 and 2, physics students take foundational courses, and so that they are in the same page. They're on the same page. But in year 3 and 4, we have a bunch of advanced courses. So note here that we have 2 types of degree in physics. One is called physics, another is applied physics. Okay, you can either graduate with a bachelor in physics, or you can graduate with a bachelor in applied physics. So some of you may not be too sure what is the difference between physics and applied physics. Let me explain here. What is physics and applied physics about? Physics is about specializing in how to model and understand all aspects of nature. Okay, this can range from very fundamental things, physics like fundamental particles, all the way to using physics methods to model complex human behavior, human system like stock market, for instance. So the kind of things that you take up in physics is like area in like atomic physics, chaos theory, condensed matter physics, physics of information, including quantum information theory, quantum physics, or electrodynamic particle physics, and so on. So these are physics. What about applied physics? Okay, applied physics, it leads to a Bachelor of Science in Applied Physics. What is applied physics about? Applied physics is about taking physics knowledge and turn them into technology. Okay, to turn physics theory into technology. So those who are taking applied physics will take courses like in acoustics, biophysics, nanoelectronics, which is about fabrication methods to create nano devices, quantum electronics, which is about creating the LED. Also, you have this plasmonic and metal material or photonics. What is this? This is about creating devices that manipulate light. So you have things like, so these are things that gives rise to discovery like laser, transistor, flash drives, LED, and so on. All these advanced things that you use today, they are actually created by applied physicists. Now, physics graduates have gone on to a huge range of careers, reflecting the broad training that physics and applied physics students receive. They go to semiconductor industries, and some even go to programmers in very specialized software and hardware scientific hardware and software companies. And some of them work in photonics, like ST Electronics, and some of them work in smaller company who are deep tech company. And and some of them work in IT, some of them work in R&D. So these are the survey we made, and you can see the breakdown. Here I want to highlight in SPMS we have what we call the Cooperative Education Program. This is a very special program. You can see on the right side of the slide. I would not elaborate on overseas exchanges because you can you may hear this already in other NTU talks. Now I want to highlight this Cooperative Education Program, which is a very special program in SPMS. This is a program in which high-performing students who opt to take so that we can give them internship opportunities. Even though we have offered internship to many of our students in the final year of study, but in the co-op program, this special program, they actually go for internship 3 times. One in year 1, one in year 2, and then one in between year 3 and year 4. So they go back to the same company. So they are not doing 3 internships. They have 1 internship, but it's a very extended internship. They go back to the same company. They partner with a single company. And then in the company, together with NTU, we devise a structured curriculum. So in year 1, you go to a certain department of the company. In year 2, you go to another department to learn another aspect of the company. And then in year 3 and year 4, after that, you basically know more or less how the company works. So by the time you graduate, you know what's going on in the company. So you are ready to contribute positively to the company. So this is designed with the intention that you may be well placed if you want to join a company after your graduation. Or you may want to choose another similar company. You know the inside out of the industry after graduation. So after graduation, you have supplemented your university academic education with the practical practical aspect, a practical application of the knowledge in a real world workplace. Other than that, I would like to highlight that NTU is strongly committed to undergraduate research. In SPMS, we place particular emphasis on this. Some of our faculty members are actually world leaders, world experts in various areas. And one of the major advantages of working in studying in university like NTU is that you get a chance to interact with these world experts. And I can assure you, all our professors are very friendly people. Just come and approach us. Some of our students actually started doing undergraduate research as early as year 1. I even have an example of a student who started advanced courses when he was in Army before he entered NTU, but he secured a place in NTU. Then he started to do some very advanced courses, right? Now in NTU, we have special programs like Eureka. This allows undergrads to do research and receive academic credits for their work. And many of our students do FYP, a final year project, which is really an in-depth research experience, working closely with a professor on original research topic. And then at the end of that, you can publish or you can produce a thesis to report on your discovery. Now, as an example of how our undergraduate researchers do, this is a chemistry graduate, Mr. C. Sutek. He worked with one of our chemistry professors, and he's very passionate about chemistry. He started doing research when he was year 1. And then all the way, he was undergraduate researcher all the way. Then after graduation, he worked with a very big company called Micron. Micron is one of the leaders in semiconductor manufacturing, manufacture chips. And he worked with Micron for 3 years as a chemist. And then, interestingly, he made his job obsolete. What happened is that they are doing quality control. They are chemists, and they supposed to go in and inspect using this electron microscope to inspect images of semiconductor chips that Micron produces to check for defects and other chemical impurities. Now, after doing for a while, Sutek realized that this is very repetitive. He's doing this day in, day out, very repetitive. So he wrote a computer program to automate the job. And then after he wrote the program, he actually made his job obsolete. He put himself and the whole team out of job. And this program is not only used in Micron Singapore, it is now being used in operations everywhere in the world. So you can see the impact he made. And then after this, he said, "Oh, okay, I've learned everything I need to know." So then he ended up in further studies. Now he's doing a PhD in physics in Cambridge University. Now, what do our graduates do after graduation? So you can see that in Sutek's example, he ended up doing PhD, but he didn't do it immediately. He didn't do a PhD immediately. This is consistent to our survey data. You can see that most of our students end up in industry, 92%. Only a small percentage, 8%, end up doing a PhD immediately. So there's a stereotype that says that if you study science, you need to do a PhD. This is not true. In Sutek's example, he didn't have a PhD, but he made a very big impact in his industry. So we can see that most of our students end up in the industry, 92%, and overall gross monthly salary is about 3,400 plus. This is comparable to other STEM, science technology program. For example, our math and our students from math and economics double major, this is a very selective program. More than 90% got employment within months of graduation, and they command the highest starting salary. Now, what about teaching? Teaching, actually the number going to teaching is not very high. So there's a stereotype which says that if you do science, you can only teach. This is not true. Only a very small percent go into teaching. Only about 8% end up in teaching. Okay. Although teaching is very important, yes, but you cannot say that you can only teach after you do a science degree. That's not true. Now, the choice, we know that you are facing a difficult decision because the choice of university course is actually a very important decision. But some of you who are truly passionate about doing science, you don't have to worry that if you do science, you can only teach. No, it is actually what lies ahead of you is a very, very rewarding career path, career choices. So important thing is that no matter what you study, actually there are many, many opportunities to be successful. What is important is you must enjoy what you do. You must have do what you like and like what you do, and retain your passion for learning. No matter what you choose, there are many, many opportunities out there. Don't hesitate. I can tell you that these are very rewarding subjects to study, and you can be assured that you can build a bright future for yourself after the degree. So for more discussion, we hope you can join us in the Telegram chat groups listed here. Thank you very much. We hope to see you soon.